Hey there, this is Kamal, and in this video we'll be learning about a version control system called as Git. So let's get started. Alright, so first things first, what is Git? So Git is a version control system. So essentially what it means is that it's a system or a software which tracks every single change that you make inside of your project. And it does so by creating multiple versions of your particular project. And each of these versions could be accessed through a particular checkpoint or something known as a commit. We'll be understanding what these terms mean further down the video, but before going forward, let's first understand what is the difference between Git and GitHub. So Git is a version control system or a software which manages and tracks all the changes that you make inside your code, whereas GitHub is the place where you keep the code that you're trying to create for this particular project. Both of these are interlinked and we'll be using both of that in this particular video. Alright, so in order to fully understand the usage of Git, let's first take a scenario as an example. Let's imagine you've started a project. Let's say you've created 5 files inside of the project, and now you made some changes for these 5 files, and you have also included 2 files and deleted 1 file. Now once again, after a few days, you made few more changes and you've created 2 more files. Now let's say something broke, and now let's say you want to revert the changes that you made on these particular files. If you had to do all of these tasks manually, it would take a lot of time and you would not even have track of all the files and lines where the changes were made. So in order to solve this problem, a version control software is used. So essentially what it does is that it creates multiple versions of your project. So in our scenario, a checkpoint is created for our first change, that is creating those 5 files. Now again, when we made changes, another checkpoint was created. Now let's say I want to revert back to my previous change. Using Git, I can go back to that particular version using just a single command. Similarly, I can differentiate all the changes that were made between these 2 checkpoints. So let's say I made a change in a single line. I will be able to identify which line that is and what that change actually is. I'll be able to see all my previous versions, and also I'll be able to revert to any of my code versions previously there in my history of all these checkpoints. So that is where Git is helpful and is used widely across the software industry. So now let's try to create that example in our own system and see how we can handle those things. Alright, so before deeply diving into Git, let's first actually understand some of the basic commands that we have inside of Git. So what I've done is that I've opened a project called as Advanced Git Course, and inside of this particular project, I'll create a new file. Let's name it as, this is a normal markdown file, and inside of this, I'll create a simple heading. Alright, so now what I'll do is that I'll go to my terminal, and inside of this, I'll type in git init, and I'll click on enter. So essentially what it's going to do is that it's going to create an empty Git repository inside of our project structure. So if I now list out all my files, you'll not see that particular file because that is hidden. But if I go to my file explorer and see all the files, you'll see that there's a hidden folder called as .git. This particular folder is being used only by Git, and you don't need to worry about what are there inside of this particular folder. You can just leave it as it is. So essentially what Git does is that it creates a local repository of your particular project, meaning it creates a local folder containing your particular code and its versions. And in the nomenclature of Git, we call these as repositories. So Git is actually trying to create a version of our project inside of that particular repository. And whenever we create any new version, that particular version is appended to that particular repository, and all of those versions are maintained inside that repository. And essentially repository is just a folder containing our code. And all of this is being done internally by Git. Alright, so with the previous command, Git has now been initialized in our project structure, and it is tracking every change that we make inside of all our files. So in order to see where we are inside of the Git process and understand what Git is doing internally, there's a command which we can use called as git status. Basically what this file tells is what files Git is tracking and where those files are inside the process of Git tracking those and creating a checkpoint. As of now, we don't have any files which are being tracked, but it is showing us that there is one file called as readme.md in which a change has been made, but as of now it is not being tracked by Git. So any change that you make inside that file will not be tracked in any of the checkpoints. So in order to add that to our particular tracking, what we can do is that we can use a command called as git add, give a space and give the file name. That is what is being suggested here as well. So I'll just do that, git add, give a space and add in the file name. Now once I click on enter and if I type in git status once again, you'll see that now the file is being tracked and it is saying there are changes which needs to be committed, meaning that you need to create a checkpoint and these are the files that are being changed in that particular commit. So essentially commit is a version or let's say a checkpoint in our particular project. So using this commit you can go back to a particular version or you can analyze what changes were made in these two particular versions or two commits. So we call these things as commits and each of these are represented with an ID called as a commit ID. So I'll now create a checkpoint here and I'll do that by using the command git commit, give a space -m, then give a space once again, and in the quotations you can give a message which will tell us what that commit was being done for. Okay, in this case I'll say it as initial commit. And now if I click on enter, you can see that it's saying one file changed and one insertion happened. So now if I say git status once again, you'll see that there are nothing that needs to be committed. Okay, now everything is being tracked and there are no new changes. If I let's say add in one more dot here, now if I type in git status, you'll see that it is showing that the readme file has been modified once again and now it is ready for to be staged and then you can commit that. So in order to understand what is staging mechanism, you can refer it to like this. So let's say you make a change inside of the file and similar to that particular file, let's say you want to make 10 more changes, but you don't want to create a commit for every single change that you want to make. What you can do is that you can add these changes to a staging area. So I'll say git add, give a space and file name, and now that is added to the staging area and ready to be committed. Similarly, I'll make few more changes in few more files and I'll add all those files one after the other. And whatever is there inside the staging area, I want to commit only those particular files. Let's say I've made changes in 10 files and I've added those 5 files from that. Now 5 files are remaining which are not added or not being staged. So when I type in git commit, only the 5 files which we added previously will be added into the commit and the remaining 5 will be present as it is and they will not be part of that particular commit. Now let's add a new commit. So for that I'll add the files that we have right now. Now there are multiple ways in which we can add the files. Let's say there are multiple changes and I don't need to add all those files one after the other. Since the file that is readme.md is already being tracked, I can just type in git add, give a space and then give -u. What that is going to do is that it's going to add all the files that are currently being tracked to the staging area. So when I type in git status, you can see that readme.md file is already added to the staging area. There are multiple other ways in which you can do. You can type in git add, give a space and give, let's say, star to add all the files, or after star you can give a .txt to add only the txt files, or let's say you can add dot to add everything inside of that. Okay, all the hidden files, whatever you want, all of those will be added to the staging area. If you just type in star, no hidden files will be added, but if you type in dot, all the hidden files as well will be added to the staging area if there are any changes. Right. So now that the files have been added to the staging area, I can commit. Now a new commit has been added. If I type in git status, you'll see that there are no new changes. Now let's say I want to see all the changes that I've made and all the commits that I've created. I can check that by using a command called as git log. And here, as you can see, it is defining the author and the date and time at which this particular commit was created. And one more thing that we have to notice here is that we have something called as commit ID. This commit ID is unique to that particular commit. That's a hash basically. And using this, we can roll back to any of the versions that we currently have. We'll see that later on, but for now, let's continue further. So let's say we have made another change and let's say I've added a new dot here. And now let's say I want to track this as part of the previous commit that was made. Since this is a small change and I don't want to create a separate commit just for this particular thing, what I can do is that I can update my previous commit with these new changes as well. So in order to do that, let's first list out the things that we have, and we have the readme file. So let's add that. And since it's already being tracked, I can directly use -u. Now once that has been done, I'll say git commit -amend. So what this particular thing is going to do is that it's going to add all the changes that you made to the previous commit instead of creating a new commit. And that's why in this case, we haven't given a commit message. So previously we gave it as -m, gave a space, and in quotations we gave some particular text, right? So what this is basically it's saying to create a new commit and add this particular message. And you're defining that using the -m flag. In this case, I don't want to do that. I just want to amend to it, meaning I want to append or add to it. Okay, that's what this refers to. Once I click on this, if you're using VS Code, it's going to open an editor in which it's going to say add the message for this particular commit, and since I don't want to change the previous commit, I'll just leave it as it is, or I can just say update it, something like this. And if I click on save, and once I close this, that change will be added. Now if I type in git log, you'll see I only have 2 commits now, and the second commit is now updated. Now let's say I've created another heading, and if I let's say git status, you'll see that file has been changed. And now let's say if I add that file once again, and if I do git status, you'll see that file is now inside the staging area. But let's say I don't want to go forward with this change and I want to revert that particular change which I have made, meaning that I don't want to commit. So I want to unstage that. And as you can see, they're saying in order to unstage it, you have to use a command called as restore. So let's try that out. Let's type in git restore, give a space, -- stage, and then give the file name. In this case, our file name is readme.md. Once I do that, you'll see that particular file has now been unstaged. Now let's say I don't want to just unstage it, I just want to revert all the changes that I've made on this particular file. I can just type in restore once again, and this time instead of giving this -- staged flag, I just given the file name. Now what this is going to do is that it's going to restore all the changes that we have made previously. So as you can see, the heading that we have created has now vanished. Alright, so now let's say I want to revert one of the commit that I've actually created. So let's say I have 2 commits here, right? That is second commit and initial commit. Now let's say I want to revert the second commit. I only want to have the initial commit. So I want to uncommit my second commit that I've created. And there are multiple ways of doing this, but the easiest solution would be to reset my particular head. Okay, so what that means is that our Git workflow is flowing in a single direction, meaning that from initial commit to the latest commit, it is going in a single direction. Now the latest commit would be our head and the initial commit would be our tail. So now our head is at the latest commit. What I want to do is I want to push back my head to 1 commit back. Okay, so I will reduce 1 commit, and in order to do that, I'll just have to reset my head. So there are multiple options available in this. Let's try out all these and see what these do. So let's type in git reset head, and I'll just type in ~1. So what this is going to do is that it's going to reset my head by 1 commit. Okay, so there was an error. There is no space between the tilde and head. So it's just one single statement, git space reset space head ~1. So this is going to reset my commit on my head. So if I now say git log, you'll see that there is only 1 commit. And if I say git status, you'll see that my readme.md has been removed from all the commits. And you can identify which commit the head is on by just looking at these particular things. As of now, my head is at this particular commit. So instead of saying git reset head ~1, I could even say git reset head ~10. And that's going to reset my head by 10 commits. Since we only had 2 commits, I reset it by 1. But if we had, let's say, 10 or 20 commits, I can reset back to 10 prior commits. So this is one way of doing it. The second way would be to directly get the commit ID and reset to that particular checkpoint or that particular commit. For now, let's add that commit again. So I'll just do git add -u. Then I'll just say git commit test commit. If I let's say git log, you'll see that we have 2 commits. Now I'll just say git reset and I'll just copy the commit ID and I'll paste that here. Now once I click on enter and if I just say git log, you'll see that there is only 1 commit, and when I say git status, you'll see that particular thing has been uncommitted and now it is present in our files. So all these resets that we're trying to do are soft resets, meaning the files that we're trying to uncommit will not be deleted. But apart from soft reset, we also have something called as a hard reset, saying that I want to go back 10 commits and I don't want any changes that we made after those 10 commits. I want to start from that particular 10th commit. So in order to do that, we have to introduce a flag inside the reset as well. So for now, let's add the commit once again. Now let's add another line. Okay, so as you can see, we have 2 more commits now, and when I try to use git log, you can see that my terminal is not able to fit all those things in a single line. So in order to see what we have below, we can just click on enter and it's going to scroll down and we'll be able to see everything. And once you reach the end, you can type in Q to exit out of it. But this is a tedious task, and let's say you have a lot of commits. Going through that is not that easy. You can actually compress this into one lines as well. In order to do that, you can just type in git log --- one line, and that's going to list out all the commits in single lines, and it's also going to show the short form or the shorthand notation of the whole commit ID. So instead of this particular thing, you can even use this and it's going to work just fine. So now let's say I want to reset to my first initial commit and I don't want any changes that were made after that. So I'll just type in git reset, and after this I'll type in -hard, and now I'll give the commit ID of where I want to go back to. But before that, let's copy this commit ID and let's keep that somewhere safe. So now let's try to reset once again. Now if I just say git log once again, you'll see that there is only one commit and all the changes that were done are now removed, and if I type in git status, you'll see that those changes are not tracked anywhere now. Alright, so that is well and good, but let's say you did this particular thing unknowingly and you don't want that thing to affect, and let's say you want to bring back a particular commit that you had made previously. In this case, let's say I want to bring back the third commit or second commit. You need to have the ID of that particular commit. So in this case, I've copy pasted the second commit ID, right? I can just copy that once again and I can just say git cherry pick. I'll just give a space and type in the commit ID, and now if I click on enter, it's going to re-add that particular commit to my commits once again. So if I just say git log, you'll see that we have 2 commits now and we have the second commit back once again. In this way, you can bring back the third commit as well if you have the ID. We don't actually have that commit ID present anywhere in our system. So the way that we can restore that particular thing as well is by using a command called as git space reflog. It's going to list out all the activities that we had previously made. And as you can see, we also have a commit called as third commit. We also have the test commit and all the amends that we had actually made as well. And as you can see, this particular ID is our commit ID. If I copy that and if I say git cherry pick that particular commit ID, you will see that particular file has been restored. So if I say git log, you can see that we also have the third commit present here. Alright, so now let's try to understand the concept of branching. So right now, if I type in git status, you'll see that Git is telling us that currently we are on the main branch. So essentially what a branch means is that in our Git workflow, whenever we are making any change, all of these are kept on the main branch. But the hard and fast rule is to never make changes to the main branch, because main branch is the branch that we generally use to deploy our code. So basically the code on the main branch is the most stable version. So whenever you're trying to create new updates or add new features, what we do is we create sub branches out of it. You can think of it this way. Take the example of a tree. A tree grows upwards towards the sky in a single trunk. And in between the trunk, there are few branches coming out here and there. And all of these branches have its own different leaves and flowers. Similarly, our commits are generally present on the main branch or the trunk in this case. And in between, whenever we want to make any new updates or add new features, we create a sub branch from the main master code or the main code. This can be pictorially represented in this way. So we have a main branch consisting of, let's say, 2 commits, that is the first and the second commit. Now what we can do is that we can create a new branch called dev. Now on this branch, we can add, let's say, 1 commit saying third or fourth commit, something like that. And we can make the changes, and when you see the code inside of the dev branch, it is having the base 2 commits, then has two more new commits, that is third and fourth. Now, when you go back to the master branch or the main branch, you'll see that there are only two commits present and the dev branch commits are not present inside of the master branch. That means it's untouched. So there won't be any issues which will be created because of the changes that we are making on the dev branch. So in this way, we make all of our changes on the dev branch, and once we are ready, we merge the dev branch to the main branch. And then from that point, the main branch is updated with the dev branch code, and now the main branch contains the final version of our code project. Alright, so now let's try to understand that through the commands as well. So right now we are on the main branch. There is another way to find out all the branches present inside our Git workflow, and that is by using a command called as git branch -v. This will show the branches which are present inside our local repository, and as of now we only have one branch, that is main, and the latest commit inside of that is third commit. Now let's say I want to create a new branch using my main branch as the base. So for that I'll use git branch, give a space, and then give the name of the branch that you want to create. In this case I'll give it as dev. If I click on enter, and let's say if I try to type in git branch -v once again, you'll see that now we have two branches, that is main and dev, and the code inside these two branches is same. And as you can see right now we are on the main branch, which is indicated by this asterisk. What we'll do now is we'll jump onto this dev branch and we'll start making our own changes to the code from here. So in order to jump to that, we have another command called as git checkout. Once you type that out, you have to give the name of the branch that you want to check out to. In this case I want to check out to dev branch. I'll just type that in, and you'll see that we have a notification saying switched to the branch dev. If I now type in git branch -v, you'll see that now we are on the dev branch. You can even find that out from the get status command as well. Alright, so now let's start making few changes. Let's create another heading, and now let's type in get status. You'll see that there is a change in the readme file. So let's try to add that and create a new commit. So now if I type in git status, you'll see that there are no new changes, and if I type in git log, you'll see that there is a new commit called as fourth commit. And as you can see here, it is saying that our head is now currently on the dev branch and it has a new commit called fourth commit, whereas our main branch is one commit behind, and this is the latest commit on the main branch. So here we have used two commands, that is git branch and git checkout. We can actually combine that into a single command and create and also check out to a different branch on a single command. And the way that we can do that is by doing git checkout, then give a space and -b, then type in the name of the branch. Let's say I want to create a new test branch. If I now type in git branch, you'll see that now we are on the test branch, and now this test branch is using my dev branch as the base. Okay, so if I type in git log -one line, you'll see that the dev branch and test branch are at the fourth commit, whereas the main branch is at third commit. Now let's say I'll create another heading, and since we are on the test branch, you'll see if I type in git status, it is showing that we are on the test branch and there's a file change in the readme file. Now let's add that in and let's create a new commit as well. So as you can see here, the test branch is now on the fifth commit, whereas the dev branch is on the fourth commit, and the main branch has the latest commit called as third commit. Now let's say I check out to my dev branch. If I type in git log once again, you'll see that we only have history regarding the dev branch, whereas the test branch is not visible anymore because it's ahead of the dev branch. Alright, so now there are a few differences between the dev branch and the test branch. So now let's say you want to keep both of these branches in sync. There are a few scenarios that you have to keep in mind when merging these branches into one another. The first scenario would be, let's say the dev branch, that is a base branch, has a few changes which are not in sync with the test branch. Meaning, let's say I add a new change here. I'll just add this and create a new commit. If I say git log once again, you'll see that we have a new commit, 4.1 commit. Now let's check out to the test branch. As you can see here, there has been change in the dev branch saying there is a new commit called 4.1. But here in our test branch, that commit is not being reflected because when we created the test branch, we used the dev branch 4th commit as our base. So whenever there's a new change on the dev branch, we have to rebase our test branch with the dev branch's data. So this can be pictorially represented in this way. So we have a main branch in which we have first, second and third commit. Now from this point on, we created a new branch called dev, and this dev branch has the 4th commit. Now from this, we created a new test branch, and from that we created a new commit called as 5th commit. Now from here on, what happened is that on the dev branch as well, there has been a change and a new commit has been added called 4.1 commit. So now what I want to do is that I want to update my test branch's base data to the 4.1's commit. So I'll just move this to this particular position, and now our data has been updated. So now this pictorial change can also be done in Git as well by using something called as rebase. So what we'll be doing is that we will be rebasing the test branch which was created from the dev branch. So we'll just type in git rebase, then we'll type in dev. If I do that, it's going to say that there are a few conflicts which are arising in your file. Let's see what's happening here. Let's close out the terminal. Let's go to the editor, and as you can see here, the head has this change, that is heading 3. This is the chain that we added in the 4.1 commit of the dev branch. And this is the chain that we added in our test branch. As you can see, this is the commit. So what we have to do here is that we have to specify to Git whether we want to accept the incoming change or not. So what I'm going to do is that I'm going to accept both of these changes. And as you can see here, both of these lines have been added. So once that has been done, what we have to do is that we have to continue that rebase to complete the rebasing process. That is what is being shown here as well. So I'll just type in git rebase continue. Okay, so it is telling us that we have to add the files before we continue the rebase. So let's add the file as well. If you type in git status, you'll see that there is a change here. Let's copy that file name. Let's type in git add and give space and file name. And now if I type in git status, you'll see that it has been updated and added. Now let's type in git rebase continue, and that should work. So it has opened the committing editor. I'll just save that as it is and I'll just close it off. And now if I type in git log one line, you'll see that the test branch now has the latest dev branch commits, that is the 4.1 commit. So that is how you rebase your test branch with the dev branch latest code. So now this is one scenario. Let's say I want to merge this test data to my dev branch. Okay, so let's check out the dev branch once again. Now if I type in git log once again, you'll see that we are at the 4.1 commit. Now I want to merge my data from test branch to my dev branch. In order to do that, there are two ways that you can follow. Either you can reset your dev branch with the data from the test branch, or you can use the merge commit to merge both of these branches. Since the test branch is based off of the dev branch, if I just type in git reset, give a space, I'll just give in -- hard, saying that I want to do a hard reset, meaning that any chain that was made needs to be added directly onto the dev branch. And after that, I'll just type in test. And if I click on enter, all the changes that I've made on the test branch will be added to the dev branch, and now the dev branch will be completely in sync with the test branch. But this is not the correct approach to do so, because whenever, let's say, a developer has made any change, we have to first review that and then merge that data onto the dev branch. So that is the approach that any company follows. So in this case, we'll not be doing that. Instead, we'll be using the merge command. I just have to type in git merge, then give the branch name. If I click on enter, you'll see that now the test branch has been merged to the dev branch. If I now type in git log one line, you'll see that the test branch has been now merged with the dev branch, and both of them are in sync. Apart from these commands, there is one more useful command that you need to know, and that is the stash command. So essentially what this command does is that, let's say you made a change in this particular file. Let's say I've added a space here. Now if I type in git status, you'll see that there's a change in this particular file. Let's say I don't want to commit this particular change right now, but also I don't want to delete that change and completely forget what I did. So what I can do is that I can store this change somewhere else, and I can reuse that or recollect what I've done whenever required. So to do that, we can use a command called as git stash. So I'll just type in git stash. If I do that, our working directory has been saved right now. So if I just type in git status, you'll see that there are no new changes, but our data has been stored inside of a stash. Basically, it's an internal stack which contains all of our changes that we're trying to stash. So if I just type in git stash list, you'll see that there is one change present inside of this particular stash, that is this particular commit. I can either drop off this change from the stash, or I can pop that out of the stash and reuse that. Let's say I want to pop that out. I'll just type in git stash pop. If I now type that in, you'll see that the change has been re-added to my directory and I can continue on from here. Let's say I want to delete that. So let's restash it. And now I'll type in git stash list. You'll see that change is there. I can just type in git stash drop. And that's going to drop the latest stash that is present inside of the stack that is used right now. So if I just type in git stash list once again, you'll see that there are no changes present inside of the stash. So let's clear out the screen. Alright, so with this, we are pretty much done with all the commands that you need to know to use Git on your local machine. But let's say you want to collaborate with multiple people and use the same code base, then you have to store this data not in your local system, but on the cloud somewhere wherein everybody else can get that data, make their own changes and push that back to that particular cloud. And from there, you can reuse that code as well. There are multiple platforms which offer these services, and one such platform is the GitHub platform. Apart from this, we also have Bitbucket and a lot more. So for this particular video, let's use the GitHub service. So for that, let's open the browser and let's go to GitHub. So if you don't have an account in GitHub as of yet, it's pretty simple. Just create an account. And once you're done with that, you'll have access to something called as repositories. This is similar to the repositories that we locally maintain in our system using Git. So here, let's create a new repository. Let's give a name to this particular repository. So just type in advanced git crash course and I'll make this public and I'll just click on create repository. So once the repository has been created, you'll be provided with a URL that you can use to link your local repository, which is present in your system, to this online cloud repository and push the data from your local system to this online cloud. So this is the URL that you're going to use. So let's copy that. So now let's go back to our terminal and here let's create a link between our local repository and the cloud repository. So the way that we can do that is by using something called as git remote. Then let's type in add, which signifies we're creating a new remote. A remote is basically a link which is established between our local repository and the online repository. So in this case, we'll be creating a new repository and we'll be naming it as origin. So that is the name that you're going to give to this particular remote. And then you're going to give a space and add the URL of the remote. So I'll just paste that in, and if I now type in enter, you'll see that a remote has been created. So if I type in git remote -v, you'll see that a new remote has been created and which is named using the remote name called origin. So now I can push my data to this particular online repository using this particular remote. So before doing that, let's check out the master branch or the main branch in this case. And if I type in git log, you'll see that we only have the third commit. So let's clear that off and now let's type the command to push the data onto the online repository. So it's going to be git space push, then -u, and then you're going to give the remote name. In this case, it's origin. And then you're going to give the branch name. In this case, it's going to be main. Now, if I click on enter, that data should now be pushed to the main branch present inside the origin. So if I go back to the repository and if I refresh this page, you'll see that the data has been added here and this is the third commit that we had created. Now what I want to do is that I want to check out to my dev branch and push that data as well. So I'll check out to the dev branch. Now here what I'll do is that I'll just try to push the data once again using the same remote. So I'll just do git push -u origin, give space and dev. Once I do that, let's go back to the page and refresh once again. Now you'll see apart from the main branch, we also have the dev branch. So if I go to my dev branch, you'll see that we have all the remaining headings as well, and we have the fifth commit present on this particular branch. So now what I want to do is that I want to merge my data from the dev branch to my main branch. And as we have previously seen, we can do that using the merge command. But when you're working in a corporate scenario and when you're working with other people, generally when you make any change, that should always be reviewed by a mentor or somebody who's looking after you. So generally what we do is that whenever we make any change, we push that data onto the branch that we are working on. In this case, the dev branch. From here on, what we do is that we create a pull request. So what this pull request means is that we're going to merge all the changes that we have made in the dev branch to the main branch. So the way that we can create this pull request is by going to the pull request section, and from here let's create a new pull request. So our base branch is going to be the main branch, and the branch that I want to merge is going to be my dev branch. So you can see the arrow here pointing that our dev branch is being merged to the main branch, and it's saying that there are no conflicts which are going to be arised because of this merging, and it is now ready to be merged. So I can just check the changes that have been made here, and I can just click on create pull request, and here I can give a title of what I want to do, and in the comment section you can give the implementation of what you've done, and I'm going to just leave it empty as of now. So let's click on create pull request. Alright, so once the pull request has been created, whoever the mentor is going to verify the changes that you're trying to merge from the dev branch to the main branch. And once the approval has been given to merge, you can go back and you can choose the way in which you want to merge the data. So there are multiple ways in which you can merge that. If you click on the arrow button here, you'll see that we have 3 ways in which we can merge. First one is creating a merge commit. And what it means is that whenever you merge your dev branch to the main branch, apart from the 5th commit that was created, a new commit is going to be added on top of the 5th commit inside the main branch, saying that the dev branch has been merged here. So it's an extra commit basically, okay? And generally we don't prefer doing that because that's going to add extra commits onto our whole Git pipeline. The second way is using git squash and merge. Let's say when you create a pull request, instead of 1 commit, let's say you had 3 commits, and all these 3 commits are of the single change. So you don't want to have 3 individual commits for a single change. You can just squash all of these into a single commit and then merge that to your main branch. So what happens is that your main branch will only have 1 commit, but your dev branch could have had 5 or 10 commits depending on how many commits you've raised. Apart from this, the last and the main that we use is the rebase. So essentially what it's going to do is that it's going to rebase your main branch to your dev branch, similar to the rebase that we had done from the dev and the test branch. So by using the rebase function, what you're doing is that you're not adding any new commit onto the 5th commit, but instead you're just rebasing your dev branch with the main branch, and all the changes that we made in the dev branch will be added to the test branch. I'll not add any comment here. I'll just click on confirm and rebase. So now that has been done, if you go back to your code and if you go to your main branch, you'll see that your main branch also has the latest commit that we had on the dev branch. So in this way, you can create new pull requests and get it approved and merge it onto whichever branch you're aiming that for. So now if I go back to my local code and let's check out the main branch, and if I type in git log one line, you'll see that we only have the 3rd commit still in the local branch. That is because we had merged the main branch and the dev branch online in the cloud repository, and those changes are not being reflected in the local branch. So in order to actually make both of these in sync, what we can do is that we can reset our local main branch with the online repository main branch. So for that, we'll just type in git reset --hard origin /main. So what it's going to do is that it's going to reset your origin's main branch to your local main branch. But as you can see, it has not made any change and we are still at the 3rd commit, and that is because the remotes that we're trying to use are outdated. Because of the pull request that we had previously created, the remote is now outdated. So now we have to first refresh that and then we can do a reset. So for that, we can just type in git fetch, and this particular command is going to refresh all your local remotes that you created. And once that is done, you can just type in git reset hard once again, and now the data is in sync with your local branch and your online branch. Alright, so these are all the commands that you need to know to use Git on a daily basis in a regular workflow in any of the companies. So there are a lot more commands still present that we can explore, but these are the basic commands that you need to know in order to be efficient in your daily work life. So I'll be providing the link to all these commands from the Git official website in the description down below. So if you have any doubts, you can go there and recheck the commands and its examples from the official documentation. So that's it for this video, guys. I hope you have liked what you have seen till now. If you did, then please hit the like button and don't forget to subscribe as well. Thanks so much for watching, and I hope to see you in the next video.